Hello, my dear students. Welcome to today's session. Today we are going to continue the topic structure of atom, valency, isotopes, isobar, isotone, atomic number, atomic mass. We are going to cover up all of these topics. Okay, so without any further delay, let's start today's session. So, while I was explaining you about the Rutherford's experiment, I also explained you a little bit hints, I hint about the like valence shell, the orbits, how many number of shells are there. If you have not watched that video already, please go to that video, check it out. That is the, I guess, lecture 2 of this topic. Okay, so please go and check out that video. So while explaining about that, Rutherford told that how many, like he named the shells, okay, like orbits as a shells, KLMN or 1, 2, 3, 4, okay, and he gave a formula for the electron number of electrons present in a shell that was 2n to the power square, right? So now what in the valence electrons are the electrons which are present in the outermost orbit. Okay, and the outermost orbit can be different for different atoms, right? For example, let's say for lithium, the atomic number of for lithium is 3, right? So for lithium, how many atoms will be there in the outermost orbit? That is 3. Correct? So what will be the valence electrons? So valence electrons is like 1 is the valence electron. Okay, this is called as valence electron and this shell will be called as valence shell. Okay, the outermost shell is called as the valence shell. All right, I hope this is clear to you. So this is only written over here. Atom which has filled completely the outermost shell and not very active chemically. The valency of the atom or combining capacity of an atom is given by the number of electron present in the atom outermost shell. Now, you know that this is called as the valence electron, which is present at the outermost shell, and the outermost shell is called as the valence shell. Now, what is this valency? What is valency? So, valency is very easy, students. So, let me explain you in a like different way. So, suppose you have like you not suppose like you have two hands. All right, you have two hands. Now, I gave you in two hands you can hold two items. I gave you 10 items to hold. Okay. Will you be able to hold in your two hands? You cannot hold 10 items in two hands, right? Okay, forget about 10 items. Even if I'm giving you 6 items to hold, you have two hands. You can hold two items in your both the hands. Okay, now don't say me like, ma'am, I can, take somewhere here on, under the armpits and somewhere else. Not like that. Okay, you are just using your hands only. All right. So I'm giving you 6 items. You cannot hold 6 items. You can only hold 2 items. You will reject the 4 items, right? So now you will either you are now I'm giving you two options. Either you have to hold 6 items or you cannot hold any one of them. Okay. So even after trying so much, you are not able to hold 6 items. So what you will do? You will let it go. Okay, just take it. I don't need anything. I have already so much. I'm satisfied in my life, right? So similarly, here also, in case of electrons, the atoms are also sharing their electrons. Sometimes they are donating their electrons. Sometimes they are gaining the electrons. Okay. So suppose here in case of lithium, it is having one electron at the outermost orbit, and this is the second shell. Second shell can hold up to the 8 number of electrons that we know, right? 2 to the power n square formula. But if I'm giving it like 7 electrons, it won't be able to hold it. Why? Because lithium has the atomic number 3. That means lithium has only 3 number of protons. So lithium has 3 hands. Okay, lithium has 3 hands only. It can hold 3 electrons only. So if even if I'm giving like in the outermost shell 8 electrons can be like adjusted like outermost, but lithium cannot hold it. If you give like, oh lithium, please take 7 electrons, I have 7 electrons, lithium will reject it. I cannot hold 7 electrons. Okay, but lithium is still not stable in its life. Everyone wants to be stable, na? Everyone wants stability in their life. So atoms also want stability. Lithium is not stable. Why? Because the outermost shell is incomplete. It's not complete. So what lithium is supposed to do now? Lithium is supposed to donate this electron to somewhere else. Okay? Lithium will donate this and lithium will say, okay, now in my first orbit there are 2 electrons, my orbit is complete, so I am satisfied, I am stable. Okay, so this donation of the electron creates a atom to ion, converts atom to ion. Okay, so if some atoms are donating electrons or gaining electrons, and how much number of the electrons are going to be donated, that is called as the valency. So in this scenario, lithium is donating 1 electron. So what will be the valency? 1. Valency for lithium will be 1. Okay, let's take any other example. Let's take the example of sodium and chlorine. Okay, so sodium is having 8 number of proton, 11 number of protons, atomic number is 11. So the electronic configuration comes to 281. Okay, in the orbit KLM. All right, chlorine is having like 17 atomic number. So electronic configuration is what? 2, 8 and 7, right? That is the atomic configuration. So now here you can see if I am drawing the structure of sodium atom, let's draw this. Let's draw for the chlorine also. So in the first orbit there are 2, in the second orbit there are 8, and in the third orbit there is 1. Here for chlorine in the first orbit there are 2, in the second orbit there are 8, in the last orbit there will be 7. Okay, so now sodium is saying that like I cannot take because I have only 11 hands. All right, number of proton I'm considering as a number of hands. Okay, sodium is saying I have 11 hands. I cannot hold so many, I cannot take 17 atoms. It's impossible. Like not 17, sorry, 7 atoms. Because chlorine, to stabilize the chlorine in the outermost shell, there are like 7, right? 7 atoms are there. 7 electrons are there. All right. For the sodium, there is only 1 electron. So sodium is saying I have 11 hands. So with this 11 hand, I cannot hold 18 electrons. It's impossible for me. So sodium is ready to donate this one. Okay. So the valency of sodium is going to be 1. 1 will be the Valency. Okay. Now, as it is donating, so donation is a good thing, na? You should donate. Like in the society, also donation is a good thing. So it is a positive thing. So this becomes positive ion. So that's why we write Na plus. Now you understood why we write Na plus? Because donation is a good thing. Now, whom is going to donate? Chlorine is saying, like to get stable, I need only one electron. All right, because it has already like 7 electrons in the outermost orbit, and it has like 17 hands. Okay, so this is saying, okay, I have 17 hands. I'm already holding 17 electrons, but one electron I can gain and like I can adjust. You know, you can also, if you have two hands, you can easily hold 3 electrons by adjusting, somewhere else in your arms. So chlorine is saying that. I can adjust. This is the reason this is accepting the electrons. And accepting is not a very positive sign, right? So valency of chlorine is again 1. What is the valency? Valency is 1 only because it is accepting one electron. But when we write chlorine, it becomes a negative charge. Understood? And sodium and chlorine, they becomes NaCl. So this both of these are basically ions. I hope this is clear to all of you. So what is valence shell, valence electrons, valency, how we determine the valency. Okay, you don't need to learn every valence is given in this chart, but just by the electronic configuration only you can see and you can just calculate your own valency. There is a formula also you can see in any other book, like if the number of electrons are more than 4, we do it like 8 minus something, 8 in this case, this will be 8 minus 7. Yeah, that formula you can also use. Okay, but generally this is the like general concept, all right, for the valency. If you don't remember that formula, you can just you should know the concept and you will be able to like detect the valency of any atom, any element. Okay, so this is the valency. Now here you can see there are some zero, like helium. So zero means helium has two atomic number, so two electrons are present. It is stable, it is like chilled. I am stable. I don't need to like donate something and I don't need to gain something also. Na lena, na dena. Kuch nahi karna. So helium is just chilled in its life. All right. It's stable. Here also you can see there are some other like argon is there. Okay. Neon is there. They are also kind of stable atom. So their valency is 0. Okay. Na lena, na dena. Okay. No donation, no accepting. That's like that. I hope this is clear to all of you. Now let's talk about the atomic symbol. So whenever we are writing any symbol, the atomic number is written like at the bottom as a subscript and the mass number is written at the top. Okay, atomic number is always equals to the number of protons in an atom. Mass number is equals to the number of protons and the number of neutrons. Okay, I hope this is clear to all of you. Let's move on to the next topic, that is isotopes. All right. So what are isotopes basically? Suppose I have hydrogen, you have hydrogen, and your brother has also hydrogen. What do you think? All the hydrogen are going to have same mass, same chemical properties. What do you think? You know, like according to Dalton, it should be same. Dalton said that all the elements having like same kind of elements are having same mass, same chemical properties, same atomic number, like everything. Okay, but now after the discovery of isotopes, it is disproving that theory of Dalton. So basically, if I have hydrogen, you have hydrogen, and somebody else is having hydrogen, it can have different mass. Okay, so isotopes are the same element with same atomic number, but the mass number are different. Why the mass number are different? Because the number of neutrons are different. Number of neutrons are different. That's why the mass number is different. So here you can see in the hydrogen 1, there is only one proton, like no neutron is there. In hydrogen 2, mass number 2, mass 2, one neutron is there, and in the mass number 3, two neutrons are there. Okay, for same for the carbon. So carbon 12, carbon 13, carbon 14s are there. Okay, so here you can see atomic number of carbon is 6. Alright, atomic number we cannot change, because if we change the atomic number, it will be a different element then. Atomic number is not changing. Only the number of neutrons are changing. So number of protons remains the same only. Here you can see 6 sixes. Okay, that's why it is carbon, no? So neutrons are changing, and this is the reason the mass number is also changing. Similarly, one more is there for chlorine 35, chlorine 37. Okay, this is these are few examples of isotopes. There are some applications of isotopes also, like isotope of uranium is used in nuclear fuels, okay, nuclear reactors. Cobalt 60 isotope, which is a radioactive isotope, it is used for the treatment of cancer. Iodine radioactive isotope is also used for the treatment of goiter. Okay, now you know that these isotopes are present on Earth only. You know, like chlorine 35, chlorine 37, both are present on Earth. So while doing the calculation, what you are supposed to use? You are supposed to use chlorine 35 or chlorine 37, and how do you know like which chlorine you are using or what? Basically, so we have a formula to calculate the mass number for the isotopic elements. So we take a average. Okay, we calculate a average mass number. And how do we calculate that? This is the method. So suppose we are only considering carbon 12 and carbon 13. So we know that 90% of the 98% carbon 12 is present in the nature, and only 2% is carbon 13 is present in the nature. Okay, so we will calculate it like this: 12 times 98 upon 100 plus 13 times 2 upon 100. Whatever the result is, that will be your mass. Okay, I hope this is clear to all of you. This is a reason like where while doing the calculation for the chlorine we use 35.5. Okay, we generally use this. Okay, so you can also do this calculation for chlorine 35 and 37. Now, next topic is the isobars. Isobars are atoms of different elements with same mass number but different atomic number. So different elements are there. Alright, this is the reason that atomic numbers are also different. As I already told you, same element cannot have different atomic number. Otherwise the element will change. So if the atomic number is different, of course the elements are also different. But mass is same. Why the mass is same? So basically number of proton and number of neutron, when we are adding it up, mass is going to be same. Like in case of argon, potassium and chlorine, calcium, we can see that all of them are having 40 mass number. Alright, these are called as the isobars. Okay, now here you can see some differences between isotopes and isobars. Isobars are the chemicals which have same mass number. Isotopes have different atomic structure and of the same element only. Isobars have atomic mass are equal in isotopes in the isotope bars, basically the masses are equal. In isotopes masses are different. In the isobars often physical properties are similar, but here the physical properties are different. In isobars, atomic numbers are different. In isotopes, atomic numbers are the same. Isobars, we are considering different elements, but in isotopes, we are considering same elements having different masses. Okay. All right. Moving on to the next is isotone. What are isotones now? Isotones are the nuclei of having same number of neutrons. So there are two different elements having same number of neutrons, but the protons numbers are different. Why protons numbers are different? Because elements are different. As I am repeating this again, elim the number of protons is a kind of characteristic feature for any element. It's the identity. Like you have identity, you have Aadhaar card, right? What will happen if you change, if there is any spelling mistake in your Aadhaar card, what will happen? Sometimes happens na, like government officials, they do this kind of job, like sometimes the spelling mistakes also happen in Aadhaar card and it changed to any other name. So again you will rush to that office, like do the correction over there, you will fill up a form for the change in name. Because why you do this? Because your name is your identity. Similarly, for the elements, number of proton is the identity of the element. So for carbon, number of proton will be 6 always. Okay. Number of electron, number of neutron, they can change. Okay. So here also isotones are the group of those elements who is having same number of neutrons. Alright, like carbon 14 and nitrogen 15. They have same number of neutrons. These are called as the isotones. Alright, so this is all for today's class, everyone. So I hope you have enjoyed this. If you like this, please hit the like button and click on the subscribe button. Alright, so we will meet in any other video. So till then, take care. Have a nice day. Bye bye.